In 2017, the Illinois Department of Transportation funded a large pilot-scale implementation of a proposal to use grass growing on highway rights-of-way as a renewable energy source. Following a 3-year study, a multidisciplinary team at the University of Illinois concluded that the energy harvested from these public lands could more than pay the cost of mowing and replace fossil fuels with a renewable energy crop. IDOT, the Illinois Department of Transportation, maintains more than 100,000 acres of non-paved public land along highway rights-of-way. Mowing directly adjacent to the roadway is necessary for traffic visibility and safety, but the remaining right-of-way could represent a wasted opportunity, non-productive land that might be put to work for the people of Illinois. IDOT asked the University of Illinois to investigate the feasibility of planting fast-growing perennial grasses as an energy crop. For the multidisciplinary team, the 3-year project was not an academic exercise. These engineers, chemists, and biologists were determined to cover all the angles from the energy potential of the plants to the practical forces that support a biofuel market.
This project is looking at the feasibility of planting various energy grasses along Illinois highway right-of-ways from the standpoint of economics, and also from the standpoint of whether this is a sustainable process. What really interested us is that the state of Illinois and the Department of Transportation has access to lands throughout the state, and they also cut these grasses on a regular basis, so they're already expending energy. So incorporation of energy grasses would be a much more economical, a much more viable alternative. As we modeled our results, we project that we can have several millions of dollars of savings. So I think that's very exciting. We're not just talking about a study that suggested something and then, that data was never actually put into play. This actually has some real-world potential for saving the Department of Transportation some significant dollars.
If you want to look behind me and see what's out here, you'll see a lot of variation. For instance, this one in front of me is switchgrass, and the one I'm standing in is also switchgrass, but then this leafier one is big blue stem, and even though it's short now, as it starts to mature and then go into the reproductive stage, it actually will be the tallest one out in the field. Additionally, you see this prairie cordgrass here. It's very sparse within the plot, but it does have a rhizome structure that will fill in this area, and this one will put out reproductive tillers that will then be well over my head. Whereas something like switchgrass tends to be almost more bushy. The reason we chose these 4 species is because they're native to North America versus something you typically don't see on roadsides. We use cool seasons, fescues and bromes that aren't native to the U.S. So we want to just try to incorporate more of our native species within our roadsides. The neat thing about prairie cordgrass is that it is very tolerant to waterlogged and salt conditions. Typically with the roadside, you'll mow it 2 to 3 times throughout the growing season, whereas with the bioenergy crop, you're only going to mow it once. That not only reduces mowing costs, but also then allows these plants to maximize their yield potential throughout this growing season.
It's a really interesting challenge because, with all the interest in the research in biomass energy systems, they're still not a big player, and so the upfront capital costs and the supply chain costs are a really critical factor, and so that's been a really important part. Since there's not a widespread use of biomass for energy, then we have a limited supply chain. We can use this opportunity and the over 100,000 acres of IDOT land that's being mowed and potentially available to grow biomass, we can use this opportunity to help raise the supply chain and help foster it along. We're working in small ways within the department itself, and then trying to imagine larger ways by working with existing commercial actors in the supply chain.
This project will allow an element of sustainability to be introduced to the operation of Illinois Department of Transportation in a way that these grasses are going to grow whether we mow them or not. These grasses are going to grow whether we harvest them or not. We can take advantage of that. We can place that in locations where it makes sense to have harvestable biomass on the roadways of Illinois. This material is competitive with a lot of your petroleum products, particularly in rural areas, areas of Illinois that are not served by natural gas, where propane is the primary fuel used for heating. We're actually producing and displacing a cost that we can displace. That doesn't come around very often. This is kind of combining what nature can provide as a renewable versus what nature provides as renewable only in geologic time when we're talking about the petroleum-based fuels. Unless these energy grasses have dual purpose or triple purpose, if they can be used for something besides just being burnt, if they can have some refinement characteristics for other base materials that could be used in industry in the biochemical side, then it has a better chance to entering the market. Other types that can be grazed or fed to livestock in emergency purposes certainly bring it to the top of the list. And those are really some of the candidate grasses that are being looked at in this project.
The reason we are interested in this species is we would like to see which species will give us the maximum amount of biomass. We are looking at pelletizing that material. And pelletizing also, it's dictated a lot by the feedstock composition. If we don't have a control on the feedstock composition, then there may be problems like very high ash content, then that can cause problems when those pellets will be fed to a biomass to fuel conversion facilities. Biomass pellets can also be a good substitute for wood pellets that a lot of people they are using in their homes. The big advantage is the transportation cost. We can also have the higher heating values from those materials. Pyrolysis, it's a process where we heat it in the absence of oxygen. As long as we have a lot of carbon material in it, we can convert most of the carbon material into fuels. When we do pyrolysis, the first product that comes out of the process is called biocrude oil. It's a very similar kind of crude oil that we get from petroleum crude oil. We can produce similar kind of fuels from it, like gasoline, diesel, aviation fuel, naphtha, kerosene kind of fuels.
It's important to know in the beginning what the actual composition of the biomass is. How much lignin is there, how much sugar is there, how much ash is there, metals, protein. If it's high in protein, you can possibly use it for an animal feed. So knowing the composition of the feedstock coming in for a large facility would be very important, because a lot of times they have to test the raw materials as they come in. For instance, if a biomass is too waxy, it may throw off their whole industrial process. So a lot of times they have certain specs, like they would need a sugar content between X and Y, and moisture content between X and Y, and maybe an ethanol extractive content between X and Y. So they know their processes and their systems, so they have certain tolerances of what they can accept as a feedstock in a biomass refinery.
This image here shows us utilizing the near-infrared wave bands where grasses are, where pavement is, where standing water might be. And you can see these on this particular image in the gray areas, where are the most likely places where we can grow the biomass. And in those blue, the deeper blue bands, those are the parcels that we've identified where we could grow biomass at a reasonable scale. We're in the process of doing that all the way throughout the state, all 102 counties in Illinois. So here we have DeWitt County, but you can see that there is a numerous number of sites within DeWitt County where we've identified that there's a sufficient amount of biomass. The triangle here represents the location of the IDOT depot within DeWitt County. So then the primary question for us is, how do we actively establish and harvest biomass on each of those parcels and process it back at the location of the depot? What would this involve? It involves typical harvest, baling operations, transportation operations, but we have to schedule all those operations throughout the year in order to make sure that we can handle those at minimum cost. A figure like this now basically takes all those little sites. And what we learned very quickly is that some of these sites, those that are connected to the center where the depot is, those are big enough that they require at least more than one visit per those sites because there's so much biomass on those individual sites. So now the question starts to become, how do we, at minimum cost, harvest all of the biomass from each of these sites with the fewest number of trips? What's very interesting is that you don't necessarily go to 3 consecutive sites that all happen to be next to one another because each of these trips is scheduled for a different portion of the year. And depending on other IDOT operations, it turns out that we can sequence this and have it meld in with the rest of their work. The solution to this problem would be county specific, and this is the solution in this case for DeWitt County. But if you actually harvested all the biomass in all those parcels throughout the county, if you were just going to handle heating and power at the depot in DeWitt County, you actually have more biomass than you really, really need. So we started thinking about what's the real demand you want to satisfy, and at that point, which of the parcels would you select to meet those specific demands? Our first parcel is a 20% scenario, and what ends up happening is that you get biomass from some of the bigger sites so long as they're closer to the depot. As you start to add more demand, going up to 40%, you start to bypass some of the sites you previously harvested to go grab some others because they turn out to be bigger. And then you might come back and go through until you keep scaling it up to 60 and 80 and 100%, where finally you've scheduled the operations for really the entire county. We have so much biomass in some of these rural counties. If we really wanted to go get all this material, what would we use it for? Well, it turns out that there is some mandate within the state that our power plants need to become more renewable in the fuels that they're using. There are 6 on this particular map power plants within the state that all have boilers that are appropriate for burning biomass co-fired alongside coal. Each of the different colors are representing the counties that you should collect from to deliver to the power plant within those ranges. So those are multiple county ranges that are being shaded. So all these things actually boil down to cost for the most part. Our analyses, this one's showing about $22 for a megagram or a metric ton of this material. And that's a pretty attractive price. What is driving this price? Well, you can see on this particular pie chart, we've distributed the cost across the whole supply chain, whether through the whole harvesting operation, as well as the supply chain, the transportation operation.
As part of the university and all land grants across the country, and their role is to help transfer technology and help show the value of the research that's accomplished by the University of Illinois. We're at a time period fiscally and governmentally where resources are very tight and very hard to stretch. As I relate to the taxpayers, I want to be able to go to them and say, this is a valuable project that could be put in place now.